Okay, so this is the open box idea. I'm just going to explain this to you. So we started with a piece of paper. This was an in-class activity, so that's probably why you're not getting it because you weren't here. So we started with a piece of paper that had 24 grids by 18 grids. And in groups of 3 or 4, you had to cut out a box from each corner. So I cut out a box that was 2 grids by 2 grids. So I cut this out with scissors, but you had to take it out of each corner. So I cut out a box here that was 2 by 2, and down here that was 2 by 2, and down here that was 2 by 2. So when I was left, I had something that looked like this, which we call a net, right? This was a net of a rectangular prism. And I folded the sides up to make a box. So I had what we call an open box. It had sides like this, but no top on it. It didn't have a lid. Okay, no lid. So there was my box. So we then said, okay, so if the original dimensions of our graph paper are 24 by 8, what size square did you cut out? Well, I cut out a 2 by 2. So that's going to be the next blank that you fill in. So what are the dimensions now of your open box? Well, the dimensions, let's see. If I think about my open box going this way, it started out as 24, but I cut off 2 inches from each side. So started off with 24. I cut off 2 inches for this box and 2 inches for this box. So that meant this was now 20 units. And then it was 18 wide, but remember I cut off 2 units here and 2 units here. So now it's 14 units. And when I fold up the sides, how tall is it? What is the height of my box? Well, it's 2 because I cut off a 2 by 2. So my length is 20, my width is 14, and my height is 2. So that was what it asked for. So like, tell me the dimensions of your box and then multiply those together to get the volume. So length times width times height is your volume. So then we talked about, I'm trying to minimize that. So then we talked about what shape. So then we talked about what everybody else's shapes were. So some people cut out a 1 by 1. And when they did that, the dimensions were 22 because 1 by 1 means I'm taking 1 off of each side. So 24 minus 1, 2 is 22. By 18 minus 2 is 16. By my height is 1. We calculated the volume of that. Then we did mine, which was a 20 by 14 by 2. And then if we cut off 3 inches, right? If we did a 3-inch box, that would be our 3-unit box. That's a 3 by 3. So that would be an 18 by 12 by 3. So you should notice a pattern. Each one of these numbers are increasing or decreasing. Each one of these numbers are decreasing by 2, decreasing by 2, decreasing by 2. And the size of my height, the height of my box is increasing each time by 1, increasing by 1, increasing by 1. So we just started with that and we just made a pattern. We just like wrote down our pattern. So our pattern here is, let's see, 16, 10, and 4, 14, 8, and 5, 12, 6, and 6. Keep going. Let me keep subtracting. 10, 4, and 7, 8, 2, and 8. And then the last one is 6, 0, and 9, meaning that if we cut out a 9 by 9 square, if we cut out a square from our paper, remember our paper was originally 18 and 24. Well, if I cut out a chunk that's 9 units by 9 units, I lose this whole side. 9 units by 9 units. And I just end up with another flat piece of paper, right? I don't have anything that I can fold up. So you don't have any volume. Okay. So what happens if you try to cut a square larger than 8? The 8 by 8 is the largest square you can cut. So 8 by 8 is the largest. What happens to it when you cut something bigger than that? You lose a whole side. So then you go to the back page of your notes and it says, so let's see. We started with this shape and then we cut out this dimension from each corner. So we're cutting out these boxes from each corner. And I'm making these dashed lines because this is where we're going to fold it. Well, I know that this was my length and this is my width. But what happened? Well, what happened was if this is X, we're just going to let the size of the box that we cut out, whether it's a 2x2, 3x3, 4x4, we're going to let it be an X by X dimension. What kind of equation can we come up with? Well, when it was 24 units wide, and we cut out a size X, we actually are subtracting 2X. So my length minus 2X is my new dimension here. Well, what about the width? When it started as a width of 18, but we still are taking 2X's off, 18 minus 2X. So that means that my width minus 2X is a formula, like that's represents the width of my box. This represents the length. And then what was my height? Well, remember my height was just X. So we can use that formula, volume equals the height times the length times the width. And that can be the volume equals the height, which is X, times the length, which is whatever the dimension of your paper is, minus 2X, times the width, which is whatever the dimension of your paper is, minus 2X. And so then we said, oh my gosh, we have a quadratic equation or a cubic equation, right? So we have a cubic equation. And when we put this into Desmos, graphing, and I'm going to go there so you can see what happens, we used Desmos to tell us about the maximum volume. So let's go there. Desmos graphing. So I said that my volume, my capital V equals, let's see, my volume equals X times, well, my paper was 24 minus 2X times my width was 18 minus 2X. And we came up with this fabulous graph, cubic. So that's why there are 3 roots. And we said, okay, well, let's talk about what size box, what X value is going to give you the maximum volume. We know that 8 is the integer value. 8 is the largest integer that we can cut off because if we cut off 9, remember we lose a side. So 8 is the largest integer value, but what about like a decimal value? So I'm going to shrink this up a little bit more because it's taking me forever to get to the top. And then when I get to the very top right here, I notice that the value of 3.39, so we said 3.4, is going to give me the maximum volume. This right here represents my maximum volume. So this is the X value. That's the size of the box that we cut out, and that's the max volume. So I'm going to say 3.4 and 654 I'm going to say 654.9. I'm just going to leave it like that. So 3.4. So when X equals 3.4, the max volume is, I forgot what that was already. The max volume is 654.9. 654.9 units cubed. Okay, so now let's go back to our graph and let's talk about this domain thing. Like what's happening down here in the domain? Well, remember that our domain gave us, like when we use 9, we got some negative values or some 0 values for our inputs, and that doesn't make a whole lot of sense. So when I go down here to my graph, I'm going to expand it so you can see that when I let X equal 9, when I cut out a box that's 9 by 9, I have a volume of 0. And then anything bigger than 9, so any number bigger than 9, 9.1, 10, 11, those are going to give me negative volumes. And then when X equals 12, I'm going to get a 0 volume again. And then anything bigger than 12 is going to give me, I go back to the positive side. So we say, what is an appropriate domain? Well, an appropriate domain for this, the appropriate domain is in between 0 and 9, not including 9, because 0 and 9 both give me 0. Anything after that is going to give you negative values or two negative numbers that multiply together to get a positive, but it's not really a possible dimension, right? You can't have a -2 box. So if I were to continue this pattern up here, if I kept subtracting, this would give me 4. This would give me -2, right? So you can't do that. Eventually, I'm going to end up with two negative numbers, and a negative times a negative is a positive. And that's what happens when you get to the any number bigger than 12, so 13, 14. But you really can't do that because you're eliminating the sides of your squares. So we say, okay, the appropriate domain is between those first two roots. Well, what about my range? Well, I know that my range began at 0, right? But we said that our max volume, well, that's really the highest it can go. 654.9. That's the highest that I can actually go. So let's see, we've talked about the appropriate domain, the appropriate range. What if I said, what x's give a volume that equals 820? So I'm going to go to my graph. Now, I know it's not going to be an exact number, but I'm going to try to go to my graph, and I'm going to scroll to where the volume is not 820. I need to change that. I was thinking of a different problem. Not 820. Let's do 420. Let's do 420 because it only goes up to 600 something. So I'm looking for what values of x give me a volume of 420. So 420. So right here is 420. And I see that when x is 1.3, I get 420. When x is 6.1, I get a volume of 420. And when x is 13.6, I get a volume of 420. So you have three x values that give you a volume of 420. So that is the open box problem in a nutshell.